Yeah, I think we're about ready to go. Good morning, everyone. It is 9 a.m. Thank you. Thank you very much for coming. It's really inspiring to see the interest in machine learning, the interest in this topic as it makes its way through different companies, different use cases, different ways of life. And I'm very excited to be here and talk about how we hope to simplify that process. My name is Erez. I'm a product manager in the Azure AI team. With me today will be Mang and Ani from the team as we demo some of what we're going to talk about. We also have a surprise guest. One of the customers is here with us to talk about their experience, so excited to do that as well. With that, let me give everyone some context on where we're thinking about machine learning in Azure AI, and then dive into our agenda. So Azure AI is really made of three parts, sort of the knowledge mining section, the area around AI apps and agents. Where I'll focus today is the area of machine learning. It's really about those teams who are going to build custom machine learning models in the coming years. It's really about how to take the data, build the models, train those models, deploy those models, get them to production, and then scale that process. As we go through that extensive journey, through that life cycle, there's really four principal areas we're looking at. We want to be trusted and open. We believe that's a key, especially as you're building an AI solution, let alone tools for others to build AI solutions. We have industry-leading ML ops. There's operations where you're actually taking your model, putting it in production, and managing it there. The other topic, and really one that we'll delve on here, is how do we make machine learning available for all skill levels? How do we take that entry point of machine learning and get it down to a place where a lot more people can use it and then find its value? I'm going to spend most of the time talking about that. I'll talk about this economy of models, economy of custom models, the supply and demand we're seeing for models in the enterprise. We've gone through a journey with customers through their use cases, sort of learning what to build and what customers would find valuable. And I'll take you through a few steps in that journey. At the end of that journey, I'll also talk about how we're bringing it all together and how we're pressure testing it to make sure that once you've started that journey, you've taken those first few steps, we're putting you in a place where you can scale that program and grow it for your business. The session is all about you taking away a few additional pieces of knowledge. And I think we'll touch on a few use cases that tie directly into machine learning. Also talk about the principles of how we connect those use cases into actual machine learning. We'll share the tools of the trade, what we believe are tools for many skills, and give you a set of demos to demonstrate those. And also hoping that you get an understanding of how you are able to enable others in this journey as well. Let me first talk about the world of custom models. And I think this is just an amazing sort of evolution we're seeing in the past few years. I used to stand on stages like this 3 years ago, and a lot of questions were, do we need machine learning? Is machine learning taking over? What is AI going to do to our businesses? And I think we've really sort of gotten to a point where AI or machine learning has become a reality in every business. I have a few examples here. Those agents you chat with, whether you're about to take a flight or you're talking to customer service, very much as you'd expect, empowered by machine learning. Areas where you need to identify things like people, like objects, is someone wearing a helmet, is someone smoking in a gas station? That's pretty clearly something you need machine learning for. What I find intriguing is that middle spot talking about these areas that you don't necessarily say, oh, they lend themselves well to machine learning. But if you're a marketing professional today and you're looking at your lead scoring, you're looking at how to optimize your campaigns, you're going to be using machine learning in order to stay competitive. If you're in manufacturing and you're looking at your supply chain, if you're in a legal team, if you're in a financial team, there's many use cases that lend themselves to machine learning. The efficiency it brings, the accuracy it brings, the point of view it brings, and the usage of the data that it can do for you is really taking over. And we see other use cases like knowledge mining, where you have a large corpus of documents, large corpus of data, which you want to better understand or more intelligently understand. And of course, some of you may have seen this in Satya's all hands autonomous systems, right? Those robots that go into mines and sort of figure out some very dangerous tasks. You may very well sort of associate machine learning with that, but I think that middle section is what we're really seeing erupt, is what we're really seeing growing. It's like every wake of the business, every area of the business is really looking at machine learning. So the demand is quite high, it's quite growing, and to be honest, we're all on a journey to see it shaping. On the other side of that demand is this excellent report I got out of LinkedIn. It's actually publicly open. I took a few quotes that are somewhat self-serving for this presentation, but are generally true. If you look at, I chose 3 metro areas, New York City, San Francisco, and Seattle, about 150,000 people, 150,000 jobs open for data scientists. And that's quite a lot. And when you look through the industries, if you dive into this report, you'll see it's from all areas and not only regions, but also areas of the business. And it very much ties to, well, that demand of creating custom models. So, I mean, here we are, right? When we start and look at building a product or a service for everyone here, we have to accept the world that it is, as it is. I'd love us to have more data scientists. But I think data science will continue to touch every wake of our business. I think we're here for the long run. We can ask, but we can't really expect people to become PhD in statistics. And now we have this world where we're asking ourselves, well, how can we help everyone? How can we make that balance happen? This is not about making more people data scientists. This is more about bringing data science and machine learning to more people. So when we build a product, when we build a service, there's always that, what I found to be a very fun moment where we say, what if? Okay, and we play this what if game, and we spend a couple of hours on it, and people bring up all sort of what if statements. And where we ended up was we said, well, what if we can simplify machine learning? Accept the world as it is, because it's going to continue. What if we're able to simplify? And simplify is a dangerous one, right? You want to simplify, you don't want to oversimplify, and you don't want to be simplistic, but you want to make it simple enough for people to use. And it's really all about the people who use it. It's really all about the audience we're going after. It's really about all of you and the tools and the industry meeting you where you are. So with that train of thought, first thing we typically do, and we did for this journey, is look at who are the personas? Who are the people we're going to enable? Who are we simplifying this for? And we took this view, or this two-dimensional view you see here, and started thinking about 2 key dimensions. One, represented on the y-axis, is how much machine learning expertise do you have? You're a PhD in data science. You've been at it for 20 years. You really know your data science inside and out. You're probably at the top of that y-axis. Well, you're just starting out. You heard about it. You understand the merits, or maybe you don't understand the merits yet. You hope to understand the merits. You hope to get into it. You're at the bottom of the x-axis. The other axis we found to be really important is this tendency to be a coder versus a non-coder. I love Python. I love R. I want to use hosted notebook and an SDK on my local machine and work with that all day long. I'm on the code side of the dimension. I'm not really a fan of coding. I'd rather focus, in this case, on the data science. I'd rather take more of a drag and drop approach to what I do. I'm on the no-code side of this equation. And as we talk through this presentation, I'll talk about Danielle and Samantha and Dean, and to some extent John as well. And we've placed them in these quadrants as they exemplify sort of the different capabilities and align them with some use cases. You also have to think of the numbers, right? And I'm going to show a few numbers here. I think the ratios apply in whichever organizations we're in. The absolute numbers may change. So, in a very big company, you're going to have maybe 10 to 20 sort of key, strong data scientists, Daniels, knowing their ML inside out. They love to code. They're really at the bleeding edge of this. You'll have tens of Samanthas, right? They know their ML. They love dragging and dropping. They want an easy approach to do it and focus on the science, but still very strong with the science. And you'll probably have hundreds of deans, right? I know my data. I've been in data for years. I know our company's data best. I want to get more insights, more predictions, more power out of that data. I don't have the ML expertise yet. And I'll talk about John and his role in this as we move forward. Now, take that down to the scale of your company, and I believe the ratios will stay, or the way we're thinking about it is around these ratios. So, again, I said, to get this right, we believe we got to meet every one of you on where you are in the journey. I'd love to say to everyone, hey, get everyone to be a Samantha, and we'll talk then. But we know we need to meet the users where they are. We're going to go through 3 use cases, aligning how each one of the users can help us. For the first one, we're going to look at customer churn. It affects all of us, right? This customer churn, that moment when we lose a customer. And this is an example of a company who's really been adversely affected by this. They've seen it in the past few years. They want to get out of that pattern. And for the current planning cycle, they're actually using or planning to use machine learning to predict customer churn. So we're not sure what it is. We're going to try and predict it. That should enable us to get better and better over time. That's the theory behind this. So we have this company, and they have Daniels and Samanthas and Deans and Johns. Since it is morning, why don't we all raise our hands? Who thinks Danielle's the best person for the job? Anyone? Okay, we got a couple. Samantha. Who thinks Samantha is the best person for the job? Okay, who's listening? Very good. Okay, who thinks Dean? Who thinks Dean is the best person for the job? Okay, we got about a handful or 10 of people thinking about each one. Who thinks John is the best person for the job? Excellent. So we have a mixed view. I'd say not many fans for Daniel and Samantha here. I think one thing you need to look at when you choose the right person for the job is also availability. To be honest, all of them can do this properly. All of them with the approach we're giving can get this done. In this example, we're taking the example where, and it's a more rare example, where we have Danielle available. So Danielle, she has great background in machine learning, as I said. She loves and familiar with Python. She often tunes our algorithms. She also has this issue where she uses our local compute. She's really running a lot of experiments, and she often runs out of the capacity she needs to run our experiments. So I think we'll turn this over to Ani. Ani is going to show you how Danielle is going to use Azure Machine Learning in order to solve this problem.
Thanks, Erez. So let's see how we can use Danielle's ML expertise and also give her a code-first experience using our new notebooks. So right now we're looking at the new studio, and I'm going to switch over to the notebooks over here, which you'll find under the authoring tab. So I'm going to click on that. So Danielle has a couple options when she gets here. So she can either create a new notebook VM, and she can do that by clicking on this new VM button. She'll give her VM a name, and then she'll need to choose a compute size that will automatically scale to her experiment needs. But for this example, let's go ahead and use a VM that was already created. So let's just take note of this. Danielle is an ML expert, so all of this ML workflow is like second nature for her. So when using the notebook VM, she has the advantage of not having to set up, doing the additional Python environment setup. She can just go ahead and do her ML workflow here. So what she's doing here in this example is bringing all her important packages. She's calling on her workspace, and then right away reading in the data, so churn_data.csv. And then she's splitting her data into X and Y. Once she does that, might want to probably explore her data. So she's looking at the first 5 rows of her data. And then after looking at the data, she might feel like she might want to clean it up a bit. So that's why she's going through the pre-process step. And then comes the part where she's setting up her experiment. So this is a lot of code. And once again, Danielle is an ML expert. So all of this is basically second nature for her. But I want to highlight a couple things for you. Throughout her experiment setup process, she's actually logging important information. Like she's logging the folds, she's logging the parameters. If we scroll down a bit here, she's logging the test accuracy and the train accuracy, and she's also registering her model. All of this information is important for her so that she can manage it later on in her workflow. So let's just continue to go through this notebook, and by the end of this, Danielle's going to end up with some important metrics that she can use to analyze her model. For example, she gets her test accuracy and train accuracy right from her notebook. Great, but what if Danielle wants to go ahead and view this outside of her notebook? So in order to do that, she can look at all the information that she logged right under Assets. She could click on Experiments, which I'm going to do right now. And then we're going to find the notebook that we just created, Notebook VM Churn Manual. So this is the experiment that we created, so I'm going to click on that. So from here, Danielle will see all the runs that she completed, and we could click on maybe run 8, which has completed under the status. On this page, she'll see important information about her run, from the date it was created, how long it took. She could see the test accuracy and train accuracy that she had logged. And if she wants additional information, she could go to the Metrics tab over here. And what this does is it gives her a visualization of her data in both chart form and also in a table form. And she could use this to understand her model better. And if she runs into any issues throughout the process of creating her model, she can look at the logs in both the Outputs and Logs tab here. Additionally, by the end of this, she'll have a JSON format of her entire experiment. Great, so we saw all the information of how she got her test accuracy, train accuracy, important metrics, but where did the registered model go? In order to see that, we could go under the Assets section. We'll see Models over here. And right away, we see that Notebook VM model. And we could also search for it right here. And there we see our model. And that's the power of using the notebooks. Back to you, Arez.
Thank you, Anna. So I think one thing to keep in mind for Danielle, she's all after the code-first experience. We built a new studio experience to bring all of that together, but we're keeping for users like Danielle that code-first experience. Danielle can also use the SDK outside of this hosted notebook and our notebook of choice, and still be able to track the assets, still be able to monitor what she does, and most importantly, register everything she does in the model registry. So when you think about this, here's how we're seeing Danielle. She does not want a new workflow. She wants to enable machine learning at the way she's used to. She's looking for flexible compute she can ramp up as the experiments grow. What we're looking to do is provide that familiar workflow, make it a code-first experience. We're going to let Danielle, based on the quota she was assigned by IT administration, provision a VM at the size she needs to, and then also, and very importantly, share her work. You'll see this coming through in the different use cases we're talking about. This notion of sharing your experiments, sharing your models is key, as they'll start coming from multiple silos within the organization. Okay, so that's Danielle, and we sort of found her on the first stop of our journey. As we continue that journey, again, we're going to dive to another use case here. And this one is looking at sales prediction. It's interesting, right? We're seeing a lot of retail activity when it comes to machine learning. There's a lot of value, ROI, retailers are able to pull from that. Reason being, they have a lot of historical data. In addition to the over time historical data, they also have data that continues to accumulate on a regular basis, especially when you're an online retailer. And most of the retailers now have sort of this online idea. Now, their sales patterns are also non-trivial. And it's quite complex to get these predictions right. The ROI has to do with, you know, it doesn't say that here, but it's mostly about their customer satisfaction. That's what we keep on hearing. That ROI of understanding how we predict sales lets us have the right inventory in place, the right set of customer support people, and that helps predict not only how much sales we're going to do, but at the end of the day, what kind of customer satisfaction we have. So again, looking at the same set of experts, you're already guessing we're not going to talk about Danielle again. In this case, what we wanted to do, since this is more of a complex machine learning problem, we want to show how Samantha would go after this problem. So again, just to recap, Samantha is familiar with the data. She also knows machine learning. She's not deep into coding, and she wants to use ML for her work in order to get this prediction right for her company. So we have Mung here from the team, who's going to show you how to use the designer in the new studio to get the sales prediction in place.
All right. So now I'm Samantha, and I want to have something different tool than Notebook, which is easier for me to use. And I'm going to the designer. The Azure Machine Learning Designer is a drag and drop tool which can help you build your machine learning model quickly. So similar again, we can go to the authoring tab and choose the designer. And in the designer, we offer a rich set of the samples to help you quickly learn the thing. But for today, I'm going to build a model from scratch. So here is a designer canvas. And we can see on the left side, there is a rich set of the pre-built modules. Basically, you can think about the building blocks to help you and build your machine learning model. And it widely covered from the data sets and to the data manipulation and feature engineering, training algorithm, and model evaluation. So basically, you name it, pretty much have most of the things you needed for your machine learning need. So for this thing, so we are going to start from our, let's see. Let me drag our training data over here. OK. I'll quickly have a look of the data. So it's going to give me some visualization of what data might look like. And I can see I have roughly 10,000 rows of the sales history data. And there's a bunch of information over here. And my job is basically predicting the sales number over here. OK? So as a data scientist, I know the basics to say, moving forward, I need to split my data into our training data sets and our test data set. So I can, using this pre-built-in module called split data, and connecting the dots over here, then I say, I'm going to have 70% of the data goes to training and leave the rest 30 for test. And now I have my data. The next thing is I'm going to pick up algorithm. So I can go to my algorithm tab. And as a sales prediction model, and it's pretty much a regression problem, so I just pick our regression algorithm. I'll use the simplest one, the linear regression. And now I have my algorithm. I have my data. I can train my model. So now here I can tell the trainer to say, using the linear regression with the 70% of the data I just got, and train a model against sales. Now I save it. It's pretty much, if I run it, I get my model. And I just want to do one more thing and to see the model performance. So I'm going to score the model with the test data using the model I just trained. And finally, I'm going to just evaluate the model and to see the performance to see if it's a good model so I can use it for production. Now, pretty much I'm done. And I just need select a compute target. And here, basically, Azure Machine Learning can let you create all different kind of a compute target. You can use a small compute target for simple machine learning, or you can create our big cluster if you need a complex machine learning. So I just randomly select one. And now I can run it. I'll select experiment. So later I can visualize the thing in the experiment page, what Annie just showed. And here I click run. What's happening here is basically the designer going to compile the graph into code and submit the code to the backend of the Azure Machine Learning and to run it. And when it's finished, it will return the results back to here. And now I can see my model performance over here. This is the typical regression matrix where we can have a look. It's And we can see whether it's a good model, I can use it, or I can want to iterate more. And here, I already have my model trained. The next step is how to bring this to production. So what I can do here is I have my model trained over here. Then I can go to register my model as for, like, for example, sales prediction, and register a model. So later I can use that for deployment. All right, now the model has been registered. As what Annie just showed, it's going to show up the model in the assets. So if I go to the model tab, and we can see the model we just trained going to show up here. All right, back to you, Aris.
Thank you, Mark. And I think this is a great view of sort of the end-to-end of what a data scientist would do using this experience. Keep in mind, this is not going to be a one iteration process. We showed you one iteration, sort of Monk showed how Samantha would evaluate the model. Samantha would continuously iterate until she hits the right accuracy, until she gets to the right parameters, until she's satisfied that the sales prediction would actually be useful, and only then turn this over to the model registry. So we'll get back to the studio later, but for now, I want to, again, touch on Samantha. This is what she cares about. She wants an easy way to work with machine learning. She's looking for scale, because these jobs, while we showed you a simple, straightforward workflow, get quite complex quite fast. They require all types of compute, like GPU, like multiple cluster CPUs she's going to need. And she also wants to customize what she does. So the idea is, in the context of this ML Studio, we're going to give you a simple drag and drop functionality to get that iteration going. There's going to be a set of standard modules that Monk showed, but also multiple custom modules that support R and Python, so you can further customize what you do. And again, this is all layered on top of the compute system that Ani showed earlier and allows Samantha to scale. So we went to a couple of stops in our journey, but where we meet most of our people, or most of the people using this and building models, or wanting to build models, or on their first step into building models, because that's where we typically see them, is really the next stop. And the third and final stop we're going to talk about is using this use case of energy forecasting. So there is, you've been hearing a lot about the energy companies in the news lately and how they're managing energy, shutting off parts of the grid in order to make that happen. Those patterns are, turns out, continuously changing. These are not set patterns. They have a lot of historical data, but these patterns continue to change. The need to balance this energy is acute for them. Well, it's acute for their customers to make sure there's a constant flow of energy into their houses, but it's also acute for them in order to make sure they have a proper ROI on what they're doing and they can actually serve the customers based on their promise. In this case, since we talked about more of our ML experts, in real life, this is what we got here, we're going to talk about Dean. So again, you'll see more deans in your organization because data and data expertise has been there for longer. And Dean knows the data inside out. He's fluent in business intelligence, and more importantly, he understands the data below it. When you do proper machine learning, the world of data for business intelligence may not be enough. You'll see a lot of asks say, hey, we need access to raw data. We need access to raw data in production. You're going to hear that quite a lot, and we've seen these companies, and ourselves too, develop the means to provide that data. Dean understands what ML can do for him. He's been in sessions like these. He's read a lot through it. He understands the power of it. He does not have that much time to experiment. And to be frank, what we're also seeing with the deans, they're under a lot of pressure to deliver. Things like, hey, you know all this data. Why don't you use machine learning to give us more out of it? Why don't you use machine learning to further provide insights and predictions you haven't given us in the past? So it's a bit of a stressful situation for the deans of the world as well. And as we were thinking about the deans and what really matters to them and the companies that work with them, that's when we started developing the idea of AutoML, automated machine learning. We've been at it for quite a few months at this point, probably started a couple of years back. This work is based on a lot of work we did in MSR, the Microsoft Research arm. And today, we're going to show you the AutoML UX experience in the context of the new studio. Turn it back to Ani.
So let's see how we can help Dean and his data-driven idea. So we're going to hop onto automated ML over here. And what we're going to do is help Dean bring his historical data to forecast the future load on an energy grid. So this is crucial because if too much energy is consumed, we're going to be wasting energy. And if too little energy is consumed, then there might be power outages. So we need the right balance over here. So let's go over to automated ML, which is right under the authoring tab again. So I'm going to click on that. So when Dean comes onto this page, he'll see all of his previously completed experiments. But for this experiment, we're going to go click on New Automated ML Run. So the first thing Dean will need to do is select his data set. He has a couple options over here. He could either bring it from local files, from a data store, from web files, or open data sets. But for this example, let's go ahead and use this data set that has already been uploaded. What's great is that Dean's team members can also upload data that Dean can later use. So this actually supports collaboration. So I'm going to click on Next over here. The next thing Dean will need to do is configure his run. Before he does that, he might want to view his data set because he loves data. So we're going to click on this View Data Set button, and then he gets to preview his data. And in this case, we're going to be using demand as our prediction column. And he also can get some additional summary statistics to understand his data better. So by looking at this, maybe he might realize that temp is going to have an impact on energy demand. But let's see if that's actually the case. So the next thing that Dean will do is give his experiment a name. So we'll go with NYC_energy. And then he's going to choose his target column, which is demand in this case. And then he'll choose a compute target, which is going to automatically scale to his experiment needs, similar to what Danielle and Samantha went through. And we could just go ahead with this one that's already created. The next thing that Dean will need to do is choose his task type. Automated ML currently supports classification, regression, and time series forecasting. This example is a time series forecasting, so I'm going to go ahead and click on that. And now Dean will need to choose a time column. In this case, it's timestamp, and this is hourly data. So after that, he's going to select a forecast horizon, and this is how far out we want to do our predictions. So I'm going to go ahead and say maybe 20 hours. And I definitely recommend that you check out our additional configuration settings. But for this example, let's just go ahead with this plain vanilla sample. So I'm going to go ahead, click Finish. What's happening here is automated MLs intelligently testing multiple models in parallel, and it's going to return the optimized model for you. So while this run continues to kick off, I'm going to go ahead and open up a run that completed a little earlier, just before I got here. As you can see in the status, it says completed. So I'm going to click on this. So right now, we see the recommended model. So automated ML has given us the metric value, the model name, and additional information for us to see if this is actually the best model for us. But let's just say Dean is not happy with this recommended model. He can go ahead under the Models tab to explore all the other models that we went through during this experiment. Maybe he wants to go through this profit model. So let's click on that. We see the score for this model, but he might want to explore other metrics, say R2 score, root mean squared error, and this is going to help him in his decision to decide if this is the best model for him. But if that's not enough information for him, he can also go into the Visualizations tab over here, and he gets additional charts to decide if this is the best model for him. So looking at this predicted versus true chart, he might realize that this is actually pretty close to what I want. And from there, if he decides that, he could go back to the Model Details tab, click on Deploy Model, give his deployment a name, let's just call it NYC maybe, choose which target he wants to deploy to, say ACI, and he could just click Deploy. So I will give this another name because I already deployed this, so I'm just going to say the demo ACI deploy. And now this is going to deploy, and we already saw how we were able to locate our registered models in the Models tab, and similarly from Automated ML, we could do the same thing. We could go to the Models tab over here, and right away we should see our registered model, which just appeared right here. Click on NYC, and there you go. That's the power of using Automated ML. Back to you, Rez.
Oh. OK, so going back to Dean, again, we're thinking of these pain points. And I stress these pain points quite a lot because at the end of the day, when we see a company sort of start with the journey of machine learning, we want to share some of the things you'll probably hear as you get the organization around an idea of how you run machine learning in the enterprise, you'll hear people like Dean, and these are a lot of people in the organization saying, well, I'm not sure how to get started. I am looking to predict. I'm only familiar with the basics. So what we want to do here is really pivot on what Dean feels most comfortable with, the data, and then introduce via the means that Ani showed in other areas what machine learning can do with the data. Dean can then share his predictions, and what we find is that AutoML is quite useful for people like Dean. It's also quite useful as Dean ramps up or other data scientists want to get more efficient in what they're doing, more efficient with the day-to-day, they start adopting AutoML. But I think we had enough Microsoft people talk to you, and you may stop believing us at some point, which could happen. I'd like to have Anita up here. Anita is the CIO for Little Caesars. So we're really excited to have a customer sort of on stage. So thank you for being here. Welcome.
Pleasure.
And we got to turn this on somehow.
A little button.
Yes.
Little light comes on.
Oh, OK, so first, thanks for coming.
My
Thanks
pleasure.
for using our products. Thanks for inspiring us to do more. It's a true opportunity for us. And I wanted to, maybe you could talk a little bit about the business problem Little Caesars was looking at and what you were challenged with.
Sure, not a problem. So Little Caesars has thousands of stores all over the world. Our problem that we had is we have a hot and ready model. Our goal is when you walk in the door, we have a pizza ready for you that's on our hot and ready menu, and you walk out. 3 minutes or less. That's our goal. When we hit that goal, that's great. But when we don't, we see customer satisfaction lower if we don't have enough pizzas ready. Now, adversely, I could make a whole bunch more pizzas, and then what happens is I have a lot more waste and a lot more cost to our franchisees. So we really wanted to improve that demand model. So that was a kind of, how do we make it better and be more predictive on the number of pizzas we needed to sell?
Great to know. We all love hot pizza. We use it quite a lot.
That's right.
But how does automated ML help with this problem?
Well, what we did is we wanted to add more modeling to that, more inputs, strategic inputs. So we work with Microsoft. We leverage Azure's machine learning platform. We use 2 components. For our feature engineering set, we used Azure's Databricks to load all of our historic data for all of our stores. From there, we enhanced that data with using AML's SDK open data set. So we added weather and some other local inputs from that. And so now we had the data ready. From there, the team utilized Azure's automated machine learning to create thousands of models. So they literally created a model for every store and every hot and ready product that they had. Then they ran that through 11 forecasting algorithms then to produce the models that we have today. And we also use the hyperparameter tuning to make it a lot more efficient.
Yeah, so the parameter tuning is really about making those models more accurate and more efficient as you start making it more and more specific for different stores in this area. So the next and last question, which I'm a little nervous about because I don't know the answer, is seeing you've gone through this process and have sort of started adopting machine learning in a meaningful way for the business, what's your advice for this audience?
My advice is to pick the right partner. We actually started this adventure long before we started working with Microsoft, and we were really struggling with getting those models. We probably worked about 6 months on our own, and then finally we actually engaged a couple companies, and we did an unofficial hackathon. We didn't tell them that we were comparing them and working parallel. And literally with the Microsoft product, we were able to do all of this in less than 3 weeks.
Good.
So we were very happy as opposed to 6 months. So it was great.
Thank you. Thanks for sharing your experiences. Anita will also be here a bit after the session if you want to get the real true answers of what she learned. I think she'll be happy to answer it. Thank you. Thanks, Anita. Thank you very much. Yeah. So, I mean, we also learned a lot from the experience with Little Caesars, and I think Anita touched on a very important point as you get into machine learning. This notion of, hey, we're not sure. The tools are expected to be available. The data is expected to be handy. This notion of, hey, let's do a hackathon. See what we can come up with. See what really has product truth behind it. See what really fits us where we are on our journey is really a great way to start. I'm glad we ended up being the winners in that area. But to be honest, we do that more often. We recommend that more often to customers as it really brings out sort of the key nuance and data. So we talked about these three experiences and these three approaches and case studies. And as we learn more and more about them, probably in the last year, we've delivered these experiences over one common platform. So we've done a lot of work to bring them over one compute platform, to bring them over one set of experimentation tracking and model registry, as I talked about earlier. And what we first did is, I'll go back to our personas here for a second. There's certainly an affinity between where you are in this grid and what tool suits you the best. I say affinity because you'll see Samantha's using notebooks and Danielle using the designer and Dean, as they ramp up, starting to use notebooks and designer as well. So definitely an affinity and a comfortable place to start. You don't always stay there. You may grow out from where you are or even go deeper from where you are. But we thought that's not enough. We also got to bring these together. So this week we're announcing the new Azure ML Studio. You can actually hit all of what you just saw on ml.azure.com. And what ml.azure.com does is it brings together those authoring experiences we just showed in this blue box on the top here. It gives your data scientists, the different teams, a studio where they can go and use all their ML assets. And more importantly, or just as important, I should say, it also holds that model registry. So as those models get created, scientists at all levels will continue to iterate on them until they get more and more accurate. At some point, they'll get to a point where they say, well, it's good enough. We're going to register it. And that's where that registry point happens. So, we've gone through this, and here's the next thing you want to do before you claim simplify, or to feel more comfortable we're claiming simplify, is we're also thinking of that point where this won't be enough, okay? No matter where your company is on a journey, maybe you have all these personas, maybe they're already building models, maybe you're just starting out, maybe you built your first model, maybe you're thinking about machine learning and want to hop into it. We know you'll get to a place where this approach of manually creating models and manually working will not scale for your needs. And we feel before we can claim simplify, and frankly, before we can responsibly put a tool in your hands, we have to make sure there's a scale option out of this. Anita talked about multiple stores. I'll talk about a few more examples. So what we challenge ourselves with is, when scale happens, what is it going to mean? What is it going to look like? And I have this very annoying colleague at work, and he says, well, when you think about scale errors, and he says this about everything I do. He says this, to his credit, he says this about everything he does as well. He says, don't think scale. It's too abstract. Think 10x. No, if you knew me just a bit, you know this would never be me. I would never do this. This stage is too high for me. But this idea of 10xing, right? So let's say we build this program, and you get the Samanthas and Deans and the Danielles aligned. You may have, a handful in some cases, maybe tens. Huge companies would have hundreds. But we're going to look into the world and see, well, how many models are you going to need? And if it's thousands and tens of thousands as we move forward, you're going to hit that scaling function. So you've got to think more around not 40 or 50 people, but rather 500, 5,000, or even 50,000 models that support your organization over time. So we said, okay, let's test that first and say, and ask this question. Will you typically need more than one model for a business case? Now, spoiler alert, I'm going to give the answer now. The answer is yes. But I'll explain how we're thinking about it via a couple of examples. and then we'll show a quick demo of how to get this done. So I was thinking if we use this, because this is not a pure machine learning example, but I think it's a good first example to understand the notion here. So what happens if we predicted the weather for the US? Just one prediction. Trust me, I live in Seattle. I would never be happy. Some of you live here, might be happy all the time, but it just won't live up to the accuracy, the up-to-date values you need. It won't live up to a place where you can personalize it or customize it. So you'll end up, just like we do in weather, with something that looks more like this. Now, in weather, to be honest, these are not typically machine learning models. These are physical models or mathematical models. But the point is, they're used in multiple regions and multiple areas. So I'll pull back the first use case we looked at. And again, if we do sales forecasting for the US, it's sort of fun, but it also sort of useless. It's not actionable. It may be good as a vanity metric an organization would look at, but it doesn't really tell the story. It doesn't say, hey, where do we need to prepare for more customers? Where will we need more support staff? Where can we reduce our staff because we don't expect too much to happen? Where do we want to push on inventory? So we really want to look at something like this. We want to look at a more nuanced view. We're going to say, well, how is sales prediction going to happen in each one of those areas? And that would require us to build a more specific model or train a more specific model. Now, think of this simple example. Think of the stores Little Caesars had. Think of these companies with all those ATMs out there, each needing a model. Think of your predictive maintenance needs if you happen to run an elevator company or you have some manufacturing. Think of the different regions that have their specific data and how you leverage that data. For the machine learning program to work and be effective, it's not just about, hey, we got them all out there, we got a process, we've registered it. You got to be in a place where you use the proper set of data to get really accurate. So what we'll attempt to do in this quick demo is show you how we use the same machine learning code, the same data science knowledge with different sets of data in order to achieve that. So I'll turn this back over to Monk to show us how we can train many, many models.
All right. So Eras has talked about Dean, Daniel, Samantha a lot, but he doesn't talk about the John too much. I'm the one, now I'm John. So I know how to code. I probably don't know any machine learning, but I want to do the job what Eras just described. I want to scale the thing from one model to every region of my model. Previously, we have seen the Samantha has using the designer and to create our sales prediction model. Now my job is basically just do the same thing, take whatever Samantha has been developed and apply that for every region. And at the end, I should have the model trained for each region, okay? So what I'm going to do here is here's the work what Samantha has been done. I'm going to package all of them and then publish them into an Azure Machine Learning pipeline endpoint. The Azure Machine Learning pipeline is basically the way to operationalize your machine learning tasks at scale. So once you have the endpoint published, basically you can rerun the job as many times as you need. So let's see how we can do that. And here's the thing. Before I publish Samantha's work, there's one thing I want to do is basically, this is the sales training data Samantha was using. I'm going to make it as our parameter. So later, I can assign different value and to use different regional sales data to train the same, go through the same graph and train the model differently. Now I have my regional data parameter set up, and I can publish it. Oops. I think I haven't used this for a while. Let me do a quick refresh. All right, so let me double check. All right, now I publish. Oh, something goes wrong. Okay, so I'm going to skip the publish part, but what you can imagine is basically I can publish a pipeline, and after the publish, I'm going to see the endpoint which I just published. I think it's some network issue. I couldn't refresh. Hold on. All right. So this is previously what I published, our pipeline over here with a parameter I just set. And this is the endpoint over there. And I'm going to use this endpoint to rerun the training experiment many times. Now I'm John. I know how to program. So I go to the notebook. And here, I have a bunch of sales data for each region, Arizona, California, you name it. And what I'm going to do is I'm going to use this regional sales data and train the model. So let me open a notebook, which is the 10x training. All right, so this is a very simple notebook. What does it do is just upload the data to the Azure Machine Learning and create our data sets. And after the data set has been created, the job we're going to do is basically just using the endpoint we just published and assign the value to the regional data, the parameter we just set, and run it. And when it's finished, I'm going to register the model at the end. So after all this done, I will show, have the trained model for each of my region over there. OK, so it will take a while. So now we can see it start running. So we have the endpoint. And it was starting processing the Arizona data. Now it's basically running the pipeline, everything. And you can see, you can imagine when it's finished, it will be there. So it takes some while. But once we finish, we can go back again to the model tab over here. And I'll just select all the sales thing. So I can see all the model we're going to train. Oh, this one is just trained, Arizona one. So, and with the regional model. All right? Back to you, Iris.
So again, take the basis of the data science you put in place and you've enabled others to do. Take the unique data you have, marry them together, and end up with this many model approach. So again, looking at John, who we sort of neglected throughout this conversation, he's going to use the AML pipelines. And I think we need to turn off your mic, yeah. And it's really about how he's able to reproduce these jobs. He wants to keep the models accurate. John is the one who's going to stay compliant with the different enterprise asks. And John doesn't know much about machine learning. He knows a lot about scale. So again, we want him to leverage the code. We want to maximize the use of the data assets and have him, as he works with Azure, align with the IT governance. So, OK, I think we're just about at the time. We covered quite a lot. And I urge you to go and use ml.azure.com. Sort of try this yourself, give us feedback, perhaps start ramping up your program. I think in a session like this, it's important to call out the 3 takeaways that I'd love everyone to have. These are based some on what we talked about, some on the learnings we had, is you'll see a lot of machine learning getting done in the organization. Make sure, as you drive the program, you identify the business problem you're going after. Otherwise, it's sort of a bit of a chase after the unknown. And it's sort of hard to end and hard to say, when is the model accurate enough? Where can it serve what we do? But sort of challenging the organization to say, just like we heard from Little Caesars, hey, this is my business problem. I believe ML can help. Please help me, sort of sets the right stage. So that's 1. Find the business problem. 2 is we talked about the personas you'll see out there. The personas are either here in the organization or you can enable them. Make sure you find them and align them with what you do. And as you think about the process, you're going to have that scaling moment where you want to have more accurate, more regional, more specific inferences and predictions. And that's when you'll sort of kick off the 10x process. It takes time to get there, as steps 1 and 2 are involved and require a lot of rigor to sort of get done. But our promise to you is once you get there, the ability to scale is right there at your fingertips, and we're not going to put you at a dead end. We have a bunch more sessions today. If you're interested in more topics, we had some yesterday, so those are gone. We have today and tomorrow in different areas. Again, I want to thank everyone who took the time and came here. This is an inspiration for all of us as you use the product and give us feedback. Thank you very much. We'll be here.